Hello students, in this video we are going to see the model formulation for non-linear programming. I have already shared one video where non-linear programming, how non-linear programming can be solved using Excel solver previously. In this video I am just going to demonstrate an application for non-linear programming model formulation. But before we go to that, I will tell you the first part, which is a linear programming part for the same application, which is on page 60. I'm just taking you there on page 60. So this is in chapter number 2, where a simple maximization problem is explained. So we will first understand this and then we will go to the non-linear part of the same problem. Par Incorporation is a small manufacturer of golf equipment and supplies whose management has decided to move into market for medium and high price golf bags. Par's distributor is enthusiastic about the new product line and has agreed to buy all the golf bags Par produces over the next 3 months. That means there is no constraint from the demand side, right? After a thorough investigation of the steps involved in manufacturing of golf bag, management determined that each golf bag produced will require the following operations. So for 4 operations are mentioned here: cutting and dyeing of the material, sewing, finishing, and inspection and packaging. And they are going to produce 2 types of bags. So one is called as the standard bag and other is called as the deluxe bag. So they have given this information about how many hours each bag of standard type and deluxe type requires in each of this department, and also the information they have mentioned here, how much is the total hours available with that department over the next 3 months. So I have put everything into this one table. So in case in the exam also, if you have given information in terms of a paragraph, you need to first convert it into a table, which like this, so that it becomes very easy for you to formulate the equations. So department, cutting, dyeing, sewing, finishing, inspection is the first column. Then standard bags and deluxe bags, production time hours are the next 2 columns, and maximum hours available is the last column. So for example, a standard bag requires 7 by 10 of hours, right, in cutting and dyeing, and deluxe bag requires 1 hour in cutting and dyeing. And in cutting and dyeing, total hours available is 630. So like this, for each department, the information is given. Now, another information they have given is about the profitability. See here, the accounting department analyzed the production data, assigned all relevant variable costs, and arrived at prices for both the bags. That will result for the profit contribution of $10 for every standard bag and $9 for deluxe bag produced. So for, if you can say that for standard bag it is $10 profit contribution, and for deluxe bags it is $9 profit contribution per bag. So this is your profit, right? And then now we will start uh, formulating our first linear type equation, and then we'll go for non-linear. So obviously their objective is to maximize the profit. So let S be the number of standard bags and D be the number of deluxe bags produced. That will maximize my profits. So that is how I will first declare my variables, right? So this is my declaration of variables. Let S be the number of standard bags, D be the number of deluxe bags, and now Obviously my total profit will be 10s plus 9d based on this last row. 10s plus 9d is my total profit which I am going to maximize. So let z equal to 10s plus 9d, maximize this particular objective function subject to, see here now, cutting and dyeing. If I produce S bags, it will require 7 by 10 times S, and if I produce D bags, it will require 1 times D. So 7 by 10 times S plus 1 times D should not exceed 630 hours, because those are the maximum hours available. So like this, I am going to write this constraint equations with respect to the hours available. So this will be my constraint. So my model for linear programming will look like this. This is the first step where linear programming model is formulated. Maximize 10s plus 90, which is my profit contribution, subject to the cutting and dyeing hours constraint, sewing hours constraint, finishing department hours constraint, inspection and packaging hours constraint, and obviously S and D should be non-negative. That is my last non-negativity constraint. So because there is no S square or S cube or D square, etc. involved, this is a linear equation and linear model. Now, there is a small, if you do a small modification of this problem, which they have shown on page 367. So I'm taking you to page 367. So nonlinear optimization, this is what we are going to look at. So this is the same problem. Now they have given us additional information that the demand for standard bags is in a way depends on the price of standard bags. So PS, so there are two more variables they are using. PS, which is the price for standard bags, and PD is the price for deluxe bags. And based on this price, the demand gets decided. If the price they lower, keep it low, there will be high demand. So they have established these two equations, and these two equations are now we are going to use for S and D. So S is our demand for standard bags, which is 2250 minus 15 times PS, which is the price of standard bag. D, the demand for deluxe bags, is equal to 1500 minus 5 times price for deluxe bag. Right? So these two equations they have already given us. Now I will convert this PS in terms of S. So I will use this, keep this term here, then it will be the S will be coming here and all that. So if you look at this, PS will be 150 divided by 1 by 15 times S, right? And I know that the profit contribution is nothing but the revenue, which is the price into the quantity sold minus the cost of production. So profit is always revenue minus cost, and this is my revenue PS, and this is my cost, right? Because S is the quantity I produce. If I sell it with the price for each standard bag as PS, PS into S is the revenue, and 70 is the cost to produce standard bag. That is what they have given us. So 70 times S will be the total cost. So PS minus S will be my profitability. So PS minus 70S will be my profit generated from standard bag. Which when I put PS from this equation in terms of S, I will get the PS minus S as 80S minus 1 by 15 times S square. So my revenue from standard bags, profit from standard bag is 70S minus 1 by 15 times S square. Similarly, when I do it for deluxe bags, I am getting this equation 150 upon 1 by 5 times D square. And my total profit contribution which I want to maximize can be put as this and this, addition of this and addition of this. So this is my total profit contribution which I want to maximize, which is 80s minus 1 by 15 times s square plus 150d minus 1 by 5 times d square. Now, because my variables s and d are not in linear form, their squares are there now in our equation. This will be our non-linear equation. So, how to solve this? I am not going to explain here. I am here in this equation. In this particular video, we are just constructing the non-linear formulation for the problem. So, this is going to be my non-linear formulation. There is no change in my constraint equations as the original problem. So that will remain the same, and maximize 80s minus 1 by 15 times s square plus 150d minus 1 by 5 times d square is going to be my objective function. And when you are in the exam, suppose this one comes, you have to mention here along with these non-negative constraints, you have to mention here as even you have to write that this is a non-linear uh, equation, and you have to solve it accordingly in Excel. So this is the final answer for this particular problem. Thank you.